Hi, we're from ChemPraxis, and today we'll be discussing IGCSE Chemistry Paper 4, Variant 3, October-November 2023. For the first question, we are given a list of substances, and we are to answer the questions below using only the substances from the list. Firstly, give the name of the substance that gives a lilac color in a flame test. This would be potassium iodide. Next, what is the substance that forms a cream precipitate when its aqueous solution reacts with acidified aqueous silver nitrate? That would be sodium bromide. The only acidic oxide from the list that is given is sulfur dioxide, and hence your answer should be sulfur dioxide for C. From the list, we are able to tell that the only unsaturated hydrocarbon is propene. The product of the incomplete combustion of fossil fuels produces carbon monoxide, and hence your answer would be carbon monoxide. Give the name of the substance that is used to test for the presence of water. There are two substances that are used to test for the presence of water. However, from the list, only anhydrous copper 2 sulfate can be used to test for the presence of water, and hence your answer should be anhydrous copper 2 sulfate. For the second question, Table 2.1 gives information about particles A, B, C, D, E, and F. Firstly, give the letters of all particles which are atoms. A, B, and F are atoms. Give the letters of the particles which are ions with a charge of 2-. D is an ion with a charge of 2-. Give the letter of the particles that are cations. C is the only cation. Next, state the atomic number of A. The atomic number of A would be 5, as per the table, and the number of nucleons in B would be 33. You can do this by adding up the values. State the electronic configuration of D. The electronic configuration of D would be 288. State the group number of F. The group number of F is 5, and lastly, state the period number of B. The period number of B will be 2. This can all be determined from the table itself. For the third question, nitrogen is converted into ammonia in the Haber process. Nitrogen is obtained from air. State the percentage of nitrogen in clean, dry air. There is 78% of nitrogen in air, and hence your answer should be 78%. State the source of hydrogen for the Haber process. The source of hydrogen for the Haber process comes from natural gas. Hence, your answer should be natural gas. For the third part, complete the dot and cross diagram for a molecule of ammonia. Your dot and cross diagram should look something like this. Next, write a chemical equation for the reaction occurring in the Haber process and give the typical reaction conditions. The chemical equation should look like this, and the conditions should be 450 degrees Celsius, 200 atmospheric, and the catalyst should be iron. Suggest which of the following elements is most likely to be used as the catalyst in the conversion of ammonia into nitric acid. Platinum would be used as the catalyst. State the oxidation number of nitrogen in NH3 and NO. The oxidation number of NH3 and NO respectively is -3 and +2. We can use this answer to explain whether the nitrogen in ammonia undergoes oxidation or reduction. The nitrogen in ammonia undergoes oxidation, and hence the oxidation number also increases. Next, complete table 3.1 using the words increase, decrease, or no change. When decreasing the pressure, the equilibrium yield of NO should increase and the rate of the forward reaction will then decrease. Next, decreasing the temperature should increase the equilibrium yield of NO, and removing the catalyst should have no changes in the equilibrium yield. Decreasing the temperature will cause the rate of the forward reaction to decrease. Explain using collision theory why the rate of the reaction is slower at the decreased temperature. As the kinetic energies of the particles is lower, the frequency at which collisions are successful between particles is also lower. Hence, a lower fraction of collisions have energy greater than the activation energy. In the second stage, nitric acid is produced. Balance the symbol equation for this reaction. Ensure that all elements have the same amount on both sides. The balanced equation should look like this. For question 4, it is about sulfuric acid and salts that are made from sulfuric acid. Zinc reacts with dilute sulfuric acid. Aqueous zinc sulfate is one of the products. Powdered zinc is added to dilute sulfuric acid and the mixture is stirred. More zinc is added while stirring until the zinc is in excess. The mixture is then filtered. Name the limiting reactant. The limiting reactant in this case would be dilute sulfuric acid. State 2 observations that indicate that zinc is in excess. We can tell that zinc is in excess when the solid is undissolved and there is effervescence or bubbling. Name the filtrate. The filtrate in this case would be aqueous zinc sulfate. Name 2 compounds which both react with dilute sulfuric acid to produce aqueous zinc sulfate. The 2 compounds which react with dilute sulfuric acid to produce aqueous zinc sulfate would be zinc oxide and zinc hydroxide. For part B, zinc sulfate crystals are produced by heating aqueous zinc sulfate until a saturated solution is formed. When the saturated solution cools down, crystals of zinc sulfate start to form. State what is meant by the term saturated solution. Saturated solution is when no more solute can be dissolved at a given temperature. Explain why crystals form when the saturated solution cools down. When temperature decreases, solubility also decreases. Hence, crystals start forming. Nickel 2 sulfate crystals contain water of crystallization. When nickel 2 sulfate crystals are heated, they give off water. State the term used to describe crystals that contain water of crystallization. The term used to describe these crystals is hydrated. State why step 4 is repeated until there is no change in mass. Step 4 is repeated until there is no change in mass to ensure that all the water of crystallization has been removed. In an experiment, 0.454 grams of nickel 2 sulfate crystals is used. The mass of anhydrous nickel 2 sulfate remaining is 0.310 grams. Determine the value of X in nickel 2 sulfate crystals. Firstly, we'll have to calculate the number of moles of anhydrous nickel 2 sulfate. To do this, we'll use the formula of mole equals to mass over mR. Ensure that you're using the mass of the anhydrous nickel 2 sulfate instead of the nickel 2 sulfate crystals. So in this case, we would use the mass given 0.310 grams divided by the mR given 155. Your answer will be 2 times 10 to the power of negative 3. Next, calculate the mass of H2O given off. To do this, we'll use the mass of nickel 2 sulfate crystals minus the mass of anhydrous nickel 2 sulfate. That way, we'll be able to get the mass of the H2O given off. In this case, the H2O given off will be 0.144. Next, calculate the number of moles of H2O given off. To do this, we'll use the same formula of mass over mR. We'll use the mass of H2O, which is 0.144, divided by the mR of H2O, which is 18. We will then get 8 times 10 to the power of negative 3. And lastly, calculate the value of X. To get the value of X, we'll use the answer from the third part divided by the answer from the first part. So that means we'll use the moles of H2O divided by the moles of anhydrous nickel 2 sulfate, and in this case the value of X would be 4. For question 5, this question is about iron. Describe the bonding in a metallic element such as iron. A metallic bonding has positive ions and a sea of free-moving electrons. It is the attraction between positive ions and electrons. The diagram that you draw should resemble something that is on the screen. Ensure that it has an orderly pattern of positive ions and free-moving electrons. Explain why iron conducts electricity when it is in solid form. The electrons are mobile throughout the iron and hence allows it to conduct electricity when it is in solid form. Iron is extracted from hematite in the blast furnace as shown in figure 5.1. Give 2 reasons why coke is added to the blast furnace. Coke is added to the blast furnace to allow it to release heat and reduces iron 3 oxide. Explain how limestone removes the impurities in hematite. Limestone decomposes to calcium oxide, which then reacts with the silicon 4 oxide and produces slag. Hematite contains iron 3 oxide. Write a simple equation for the conversion of iron 3 oxide to iron in the blast furnace. Your equation should look like this. Ensure that you've balanced the equation. Suggest why the iron produced in the blast furnace is molten. The temperature in the blast furnace is above melting point of iron, and hence the iron produced in blast furnace is molten. Most iron is converted into steel, and steel is an alloy. Steel is more useful than pure iron because it is harder and stronger. Explain why the structure of alloys causes them to be harder and stronger than pure metals. The atoms of alloys have different sizes, which means that the layers cannot slide over each other, making alloys much stronger and harder than pure metals. Your diagram should look something like this. Iron forms rust. Rusting is prevented by coating iron with zinc. Name the substances that react with iron to form rust. Rust is formed when iron comes in contact with oxygen and moisture or water, and hence your answer should be oxygen and water. Name the process in which zinc is used to coat iron to prevent rusting. This process is known as galvanizing. Now explain how the coating of zinc prevents rusting if the zinc is not scratched. The zinc acts like a barrier that prevents oxygen and moisture from reaching the iron and hence prevents the iron from getting rusted. However, when the zinc gets scratched and the iron becomes exposed, as zinc is more reactive than iron on the reactivity series of metals, it will therefore oxidize to prevent the rusting of iron. And now for the last question. Esters are members of a homologous series of organic compounds. Give 2 characteristics that are the same for all members of a homologous series. 2 characteristics that are the same for all members of a homologous series would be a general formula and a functional group. Ester X has the structure shown in figure 6.1. Name ester X. From the structure shown in figure 6.1, we can deduce that ester X is ethyl propanoate. Ester Y has the structural formula HCOOCH2CH2CH3. Name the alcohol and the carboxylic acid used to make ester Y. The alcohol used to make ester Y is propan-1-ol, and the carboxylic acid is methanoic acid. State the molecular formula of ester Y. From the structural formula, we can add up all the H, C, and O's together, and then we'll end up getting C4H8O2. And that will be your answer for the molecular formula of ester Y. Ester Z has the molecular formula C4H8O2. State the empirical formula of ester Z. Your answer should be C2H4O. Polymers containing ester linkages are known as polyesters. Polyamides are another type of polymer, and nylon is a polyamide. State the term used to describe the type of polymerization used to produce polyester and polyamides. The type of polymerization used to produce polyesters and polyamides would be condensation polymerization. So condensation polymerization should be your answer for part 1. Complete figure 6.3 to show the structures of the monomers used to produce nylon. Show all of the atoms and all of the bonds. Your structures should look like this. Naturally occurring polyamides are found in food. So, state the name given to naturally occurring polyamides. Naturally occurring polyamides are also known as proteins, and hence your answer should be proteins. Name the type of monomer which forms naturally occurring polyamides. Proteins are made of amino acids, and hence the type of monomer that forms naturally occurring polyamides would be amino acids.